Alright, hello everyone. So today as usual we're gonna try to solve another coding problem under 40 minutes hopefully. So this stream is for entertainment purposes only and let's see what we got today. Another, let's see, easy, medium, hard, medium, alright. K different pairs in an array. Too many people doesn't like it, so chances are it's some weird dynamic programming and super tough edge cases and it just doesn't work. All right, whatever. Let's try to see if we can crack it. Given an array of integers nums and an integer k, return the number of unique k-diff pairs in the array. A k-diff pair is an integer pair num I, num j, where the following are true. So for every ij where I is always less than j and is less, greater or equal than 0 and j is always less than, okay, so there's always I never equal to j and they're always in the range of these nums. So the absolute difference is k. Return the number of unique k different pairs in the array. So if we sort this thing, right? Okay, example 1, 3, 1, 4, 1, 5, and the difference there is 1 and 3, the unique one, and 3, 5, right? I mean, it's easy to check the unique one because it's just all right. So the length is 10 to the 4. So sounds like they're fine with quadratic solution because I don't really see any speed ups here, potential speed ups. So we can sort the thing, all right? So let's consider this example 2. The k is 1, so we know that if it's distance of 1, and if we moved and it's already out of range for the first element, it doesn't make sense for us to continue to this one, right? So we return to 2, and then do we need to start with the 2? Or do we need to so if k is super large, right? All right, let's sort stuff. Nums begin, nums end. Once we sort, find K-diff from element from start element, right? We say int pause, int start is equal 0. Then we say while while start is less than what? Num size, I would say -1. We do this, right? So we say CPP sort. So I guess the default one sorts in ascending order, right? Not descending. Yes, it will be 12, 32, 45. All right, so that's cool. Let's keep it. Int next equals start +1. Then we say while. So I wonder if there is anything smarter than this we can do. Other than this K sliding window, it still sounds like if it's too much, we're gonna do a lot of subtractions, right? This element, and just to figure out where things are. While nums start, actually we know that this one is great, right? So nums next minus nums less than k, we say next plus plus. So once it either equal to k or less than k, And because we need unique elements, we don't care if other elements in this thing also matches, right? We just need one. Next. So then if insert if here equals k cnt plus plus, right? Once we have this and that, all we need to do, so we don't touch the next one, right? Because obviously the second element while num start equals nums new start, we say new start plus plus. And k can be equal to 0, which means we need to count unique elements. And again, this can be solved differently. In this case, if k equals to 0, we just add everything to the set and return the size of it. So it will be special case that we will handle differently. All right. So once new start doesn't equal the start, then we say that start equals to new start. That's it. Find next start. Find k-dist element. And here, or we can say if k equals 0, special case linear complexity, right? Unordered set of int unique, right? And then all we say is for const auto nums, we just unique insert num and return unique size. All right, so this is simple. Then we say else then let's do this 1, 2, 3, 4, 5, 6, 7. All right. So this thing here basically goes for every next element we go until we hit this K, right? Until we move to the next unique one, which doesn't matter, it still goes through the start, which means the linear times next. And next, it will also slide through this, but they may skip some of the elements. Because we push next only until it hits the K, and once it hits the K, we don't change the next, right? Actually, maybe let me see. It's wrong. Actually, let's have it here. We don't need this thing, right? So in this case, next will be pushed as well in parallel to start. So it can be actually linear in this case. Interesting. Yeah, let's have something like this for clarity. So find K-diff element. So we find next, right, until it's either greater than K or it's equal to K. If it's equal to K, then we check, is it equal? Alright, then increase in T. And then we start until the start element, right, becomes the next unique element, technically speaking. That's what we do. Alright, let's just see if it works. So we spend about like 15 minutes, less 17 minutes. Let's debug this. As usual, it will fail because we need to return something, obviously, at the end of else statement, which is here. So we return CNT. Or less than K and next less than nums length, right? That actually says. In this case is -1. We don't need to check the last element because it will be already prepared with someone with all other elements, with all preceding elements. So okay, all right. Let's check one more time. Maybe this will be more easier to observe. I don't know. Let's see. Slightly more lines, but this is okay. All right. Let's see where it fails, because it sounds like there's a lot of corner cases. So if the distance is 0, you technically need to find not the number of unique elements, you need to find number of pairs. So basically unique pairs means if we have at least 2 ones, then we have 1 pair. If you have at least 2 twos, then we have 1 pair. So in this case, it will be an ordered map. I would say, let's say, have int and maybe what? The boolean to say contains equal unique count num, right? And then we say unique num equal contains, right? Once it contains, then and then we have, okay, let's say another int cmt 0. We can actually have cmt here, right? So, and then we return cmt to minimize duplication of the code here. So we don't return anything here. I would say that we just need, no, we need set, so that's okay. So we need set of unique, alright? And before inserting it, what we say is that if unique count num, right? So if it's already contains num, we say, sorry, one thing else, we insert. We just say insert now. CMT++, right? So if we already have the elements, we say, right, CMT++, else we just insert now. Right. Run the code one more time just to make sure everything compiles, and then submit. Interesting. Because we have local definition, right. Submit. Now we should fail somewhere else. Hopefully. No, still here. All right. Then let's do different trick. So we have unique set, right? And then we say if it's already contains, we add it to another set. Unique pair. Yeah, I mean, why bother with these stupid formalities? Unique pair. So then we don't need it here. We can move it here. Then return SMT obviously here. Don't bother. And only if it contains already, then we say unique pair. Insert none, right? And then we return unique pair size. Oh man, run the code just to check that everything works. Extra space here. Submit. Finally, we should pass this check and move to the next case where it fails. All right, we passed everything. That's easy. That easy. Now let's see if we can save somewhere in terms of space. So we know that k is 10 to the 7, right? And we don't have any structures here, so we're fine. Maybe we can say that this is constant if we don't modify it anyway. Yeah, I don't know. So it seems nothing much we can do here. So let's see. The best scores we can get so far is 94 and 82. And I have a gut feeling that I should not resubmit it because the result will be worse. But we will see. You never know. Oh man, what have I done? Oh, because I made it const. Yes, sorry again, sorry. Jesus. Alright, memory seems better. What 89, 94. Alright, let's start here. I'm fine with this one. So let's switch to the whiteboard. So we have 94 for time complexity and 89 for space. Right. Still great. Mm-hmm. 94. Now it goes the super complicated math of saying that this is 183. 90 plus minus 1, 4 minus 1. Okay, so this is 183. All right, done for today. See you tomorrow.